All right, let's start with number 19. This is on page 56 of the worksheet. And you're going to see problems that look very, very similar to this. Let me read it. Actually, hold on just a second. All right, let's forget 19. Let's forget 19 to 21, okay? Because I'm not, I didn't put that on the test, all right? It's not that it's not important. We did cover it when we covered these lessons, but it's not going to be on the test, so I'm not going to worry about it. What I will do is this. Let's look at number 22. 22, you're going to see about 3 or 4 of these type of problems. So let's write this one out. It'll look very much like 22. And maybe I'll find some other problems. They didn't give you that many on this particular worksheet, but I have about 3 or 4 on the test. All right, looks like this. And this is 9x minus 44, this angle right here. And this angle right here is 6x plus 10. Oops. Now, we did talk about these kind of problems from the quiz. You had a couple of these on the quiz. The first 2 problems on that quiz that you took, when was it? Thursday? We went over it Friday. We went over 2 of those like that. So we've already reviewed this before, but this is just one more review. So you're going to have about 3 or 4 of these. I think 3, possibly 4. I'm not sure exactly. But you're going to have a few of these. And you have to know what to do. And the problem says, this is they call this line A, and this one line B, and it says find the value of x so that A is parallel to B. Alright, so I want to find what x is in order to make these 2 lines parallel to each other. Well, let's look at the relationship between these 2 angles. Look at this angle right here, and look at this angle right here. Is there a relationship between those angles? Yeah. They're alternate exterior angles, that's right. They're alternate exterior angles. Remember, we had a theorem that says this. We said if the alternate exterior angles are equal to each other, then the lines are parallel. And that's the theorem that we're using. If these 2 angles are equal to each other, then these 2 lines will be parallel to each other. So what we're going to do is we're going to set these equal to each other and solve for x. On the quiz, we talked about this on Friday. On the quiz, there were some problems on solving for x. A lot of you guys actually did set these equal to each other, which was good, but then you didn't solve for x correctly. So let's make sure we know how to solve for x, because you have to be able to do that. All right, it's very important that you can do that. That's Algebra 1 stuff. So let's do this. Let's set them equal to each other. So I've got 9x minus 44 equaling 6x plus 10. Now, not every single one of these angles are going to equal each other. We had one on the quiz where they were supplementary, right? So you had to add them up and set them equal to 180. These particular angles right here are alternate exterior, which means that if the lines are parallel, these angles would be equal to each other. So we're going to set this equal to this, and then we can solve for x. All right, so here's what we do. Look what we have. We've got our equal sign right here. Here's the left side, here's the right side. We have to get the x on the same side of the equal sign. Right now we have a 9x on the left-hand side, a 6x on the right-hand side. We got to get them on the same side. Probably the easiest way to do this is to take this 6x, move it over here to the left side. How do we do that? This is a positive 6x, so how do we move that whole 6x? Right. Subtract 6x from both sides. All right. So I got rid of this, and I got it on the left-hand side. So x is on the left-hand side now. That was the key. Some people on the quiz and some of the worksheets I saw put like, I don't know, you added them up. You went like 9x plus 6x is 15x, all right? You can't do that. You can't add them up. They're on different sides of the equal sign, all right? So you can't combine 2 different things from different sides of the equal sign. So we subtract the 6x from both sides. That's how we get it over here. Now we have the x on the left-hand side. Let's get rid of this 44. Well, it's not just a 44, though, is it? It's a what? It's a minus 44. So how do we get rid of it if it's a minus 44? We plus. You add a 44 to both sides. All right? And so now that canceled out. So let's add up all the stuff. 9x minus 3x is, 9x minus 6x, got ahead of myself, is 3x equals, add these up, that's 54. All right? Divide both sides by 3. What's that? 54 divided by 3. So that's, is it 18? Okay, 3, 24, 8 3s 24. Good. 18. X equals 18. And there it is. That's all you got to do. So you got about 3 or 4 of these things. All right, does that make sense? Now they don't only give you one problem like this. But what if they give you, I don't know, what if they gave you this angle? I'm not going to even try to make anything up because I don't know if I could get them to come out right. But actually, let's do this. What if they give you this angle and this angle right here? What if they gave you these 2 angles? Would you set those 2 equal to each other? That's right. These add up to 180, don't they? Now, how do you know that? Because they're consecutive interior angles. There's a lot of talking going on. Let's keep it quiet. Unless you're answering a question from me. Go ahead. Well, they're all equal except for the consecutive interior. All right? But let's take a look. Even if you didn't know the names of these things, even if you didn't know the names of consecutive interior, alternate exterior, corresponding, even if you didn't know those names, the easiest way to look at it would be this. I'll tell you what. Let's, since you asked, let's do this. Let's get rid of all this stuff right here. Okay. And we'll just keep it in yellow. Look at this. Remember what we said? All the acute angles. If these 2 angles are parallel to each other, all the acute angles are equal to each other, and all the obtuse angles are equal to each other. So let's take a look. This is an acute angle. What's another acute angle? This one right here, this one right here, and this one right here. Everybody see that? So all of these are all equal to each other. So if I gave you this angle here and this angle here, they're equal. If I gave you this one and this one, they're equal. If I gave you this one and this one, they're equal. Follow me? Okay, so all of those angles, are equal to each other. All right? Do this in another color just so it stands out, but I'll double them up too. Look at this angle right here. Now look, does this red one and this yellow one, do they equal each other? Does this red one up here and this yellow one down here equal each other? No. This is an obtuse angle. Is there any way in the world that an obtuse angle will ever equal an acute angle? No, it's impossible because of the definition of both of those words. Acute is less than 90. Obtuse is greater than 90. Is there a number that exists that is both bigger than 90 and at the same time less than 90? No, it can't exist. So all these are equal to each other. All the obtuse angles are equal to each other. You don't really even have to know the names to do this problem. All right? Now, you will have a problem earlier in the test that will say, you know, what's the relationship between these angles? And you have to say alternate interior. You got to say corresponding. You got to say consecutive interior. What's that? Will I have it on the test? Is that what you said or what? Yeah, I just said you'll have some problems that say you'll have to label them as consecutive interior, alternate exterior, and corresponding. Right. But on this particular problem, you didn't really have to know the names of these, did you? You just had to know this, that all the yellow ones are equal to each other. Just have to know that all the yellow ones are equal to each other and all the red ones are equal to each other. If you know that, I mean, they could tell you anything about like this angle right here and this angle right here, right? So what do? They're equal. What if they told you a red one and a yellow one? Then what would you do? Would you set them equal to each other? No, what are they? They're supplementary. So you would add them up and set them equal to 180. Okay, I don't have an example on this worksheet that actually does that, but we had one on the quiz. We went over that on Friday. Okay, so you can look at that. All right, so that's kind of helpful. All right, let's take a look. Now again, on this worksheet, they don't have one. They don't have one that's exactly like the one on the worksheet, but we had one on the quiz. Do you remember they gave you like a triangle and you had to find the distance from one point to another point, or from a point to a line, sorry. Remember that? So let's just make up our own. A, B, C. And they could ask you to construct, remember the words? Construct the, how did it work? Construct the line segment, that shows the distance between a point and a line. So they say from, watch this, from A to, let's say, BC. So from A to BC. So you would come over here. And again, there are several people that didn't take the quiz the other day, and so I was just grading them today, and I saw one that says from A to BC, and what did they do? They went from B up to here, or I don't know, whatever they did. But look, it's from A. You're starting at A. So where do you start? Right there. Okay, and where do you go to? BC. All right, so you don't just, let's not say straight down. We've talked about that a lot. What do we say? Perpendicular, right? It's perpendicular. And what did I also say? What did I also say about this? If you didn't do what? If you didn't draw the box, then guess what? It was wrong, okay? And I still had people not putting that little right angle box there. All right? You got to listen to what I say, and I had to mark it wrong, and I hate doing it because you kind of drew it right, but you didn't say that it was perpendicular. This line right here has to be perpendicular to BC. Now, that was like an easy version of that. But then we said there could be another one. You could do this. You could say from, let's say, from C to AB. All right, you might see one that looks like this. So where do you start? You start at C, okay, and then you have to go to AB. But do you go to anywhere on AB? No, you go where? Actually, that one wasn't as difficult. Let's do another, let me do another triangle to demonstrate this, okay? Yeah, let's do a quadrilateral. That's good, because you might see a quadrilateral in there as well. So let's do that. So they kind of made it look like this, didn't they? And then they slanted it a little bit, right?
That's not a quadrilateral.
That's a quadrilateral.
A pentagon?
No, not a pentagon. This is. So let's just use A, B, C, D. From AC to B. Well, they go from a point to a line. They don't usually say to go from a line to a point. All right. So let's say they go from. Let's go from C to AB. Can't believe I have to. Nothing. From C to AB. Let me get the line tool here. Here we go. There it is. From C to AB. So we start at C and we have to go to AB. All right? That was an easy one, right? Because I just wanted to do a quadrilateral just so that you could see it. So that's pretty easy. You go from C to AB and you make sure it's perpendicular. But what if I did this? What if I went from, let's say, from C to AD? It's a little different. From C to AD. What if I asked you to draw that? So watch. You go here, and you go to there. Do you go to there? No. Some people did that. Some people were doing that. No, you don't go to there. You have to draw it so it's what? So it's what? So it's perpendicular. Actually, you would draw it here, wouldn't you? What am I doing? Oh, I know what I want to do. Well, let's see. Where would perpendicular be? Would it be one of those? Let's see. If I drew it here, it'd probably be about like that, wouldn't it? About right in there somewhere? Yeah. That's not exactly what I was looking to do, but that would be the distance, wouldn't it? From C to AD. All right, I could ask that. I don't know if I do or not. It's not what I was really thinking of. What do I want to do, though? I want to go from where? I probably want to go from D. Let's do this. Go from D to AB, right. So that's probably what I want to do. What? Yeah. So watch. If I want to go from D to AB, here's AB right here. I can't go to there. Can't go to there. Anywhere there is going to make it less of a right angle, right? So I got to go to where? Up to here, right? So before I do that, though, I'm going to have to come up here, and extend this line, aren't it? Okay, you can make a dotted line, you can make a solid line. It really doesn't make any difference. In the book, a lot of times they'll do a dotted line. And then, so now I've extended that line. Now I go from D to AB. Now, here's what I'm going to do. I'm going to go up to here like this, and I'm going to make a right angle. All right? Now, look, don't take this and extend it up. Now, you can extend this side. See the side that we extended? That's not our distance, is it? I can extend that as far as I want. I don't care. All right? But this one right here has to start here. It has to. And then it has to end right there. It has to end there. It can't go beyond that. So don't take this. Look, and I've had a couple people do this, and I had to mark it wrong. Don't take it and extend it out like that. That would be wrong. It has to stop right at that extension mark. So it has to stop right there. If it goes beyond it, it's going to be wrong because it's a distance, isn't it? This distance is what we're looking for. I had somebody on one of the quizzes do this. It said from D to AB, but they did this. All right? Now watch, technically the distance is the same. Isn't this distance the same as this distance right here? It is the same distance. Well, it's the same distance if these two lines are parallel. Did we ever say that this line and this line were parallel? Not really. Okay, we made an assumption about it, so that would have to be wrong. All right, and it didn't start from D, did it? This started from where? From A, so that wouldn't be right. This would be right, from D to AB. What?
The test is tomorrow, right?
I'm not going to answer that because I've talked about that on several occasions, and I refuse to repeat something that I've said about 3 or 4 times already today. All right, so let's do another. Let's do this. We talked about that. Let's flip to the front, page 55. All right, let's take a look at this. I'm looking at 3 through... Well, actually, I'm looking at 6 and 7. Let's just look at 6 and 7 for right now. All right, you're going to see stuff that looks like this on the test. Now, this time they tell you that the lines are parallel. They tell you right off the bat that the lines are parallel. All right, and for number 6, it says M and N are parallel to each other. If you look at number 6, it says angle 8 is 86 degrees. So if we look at the picture, angle 8 is this one right here. And it says it's 86 degrees, so I'm going to put it in right there. And then it says find angle 13. Angle 13 is this angle here. I'm not going to put a 13 there. I'll just put a little arc, okay? So if you take a look at it, you got to know. We've kind of talked about this already today. Okay, this is actually a little easier, isn't it, than what we did before? Because you don't have to do a whole lot of algebra. All you got to do is one subtraction, then you're done. If you take a look at this angle and this angle, they're consecutive interior angles to each other. These two angles add up to 180 degrees. So you just go 180 minus 86, and what'd you say that was? 94. So that angle right there is 94 degrees. That's all there is to it. All right? Because you got to recognize that they're consecutive interior. What if I asked for this angle? What if I gave you this as 86, and then I asked for this angle right here? What would you do there? Would you add those up and add them and set them equal to 180? No, what would you do here? This angle and this angle. What's true about them? They're equal to each other, aren't they? Because they're what? Alternate interior angles. Now, we do have a series of questions that asks you to name what type of angles they are. So, for instance, this angle right here, 86, and this angle right here are alternate interior angles. You're going to have to know those words. What would this one and this one be? They're consecutive interior angles. All right. What if I said this one and this one up here? We've talked about those already. What about this angle and this angle? What are they? Alternate exterior angles. Good. All right. What if I said this angle and this angle right here? Those two. What are they to each other? They're corresponding angles. All right. So you need to know the words. I think, let me just check to see if I really have that on the test or not. So I do give you problems like this. I give you 2 problems like this, and I do give you a list of words. Okay, I tell you alternate interior, alternate exterior, consecutive interior, and corresponding. So you don't have to remember, but you need to know what they are. You should know vertical, right, because this 86 and this 86 are vertical angles. I don't think that's one of them, though, on the test. But, yeah, that's something you should know as well. All right, let's do this. Let's go to something a little bit different. Let's talk about slopes. Actually, let's do this. I'm sorry. Before we do that, let's use these same two lines, M and N. And so there's M and there's N, but let's do a different transversal here. Let's do a transversal that maybe looks a little bit like that. All right, and let's put some stuff in here. Says that angle 4 is this one right here, and it's 6x minus 5. This is angle 10 right here, and they say that that's 5x plus 8. And they say angle 9, which is this one right next to it, is 3y minus 10. And you have to solve for x and y. All right, we've talked about this before. This is nothing brand new, so let's just look at it real quick. They also say that these two lines are parallel. So if these lines are parallel, what is true about this angle right here and this angle right here? What's the relationship, first of all? When I say what is the relationship, you've given me the name. Justin, what is it? They're alternate interior angles. And if it's parallel lines, what's true about alternate interior angles? They're equal to each other, so let's set them equal. So 6x minus 5 equals 5x plus 8. Now we solve for x. We subtract 5x from both sides. Okay, that cancels out. We've done this already today. I'm not going to explain every little step. And then that cancels out. 6x minus 5x is x. 8 plus 5 is 13. And that's your answer. So x is 13. All right. But the problem is, okay, listen to this question. Anthony said if this angle right here and this angle right here, they do add up to be 180, right? But there's a problem, though. Could you do that as your first step? Why not? Carol? Yeah, we're going to put x in. But right now, we got different variables, right? So I couldn't do that as my first step.
So,
I couldn't do that as my first step. I couldn't say 6x minus 5 plus 3y minus 10 equals 180 because I have two different variables and only have one equation. I wouldn't be able to do that. So I got to look at the letters that are the same. See if there's a relationship between them. Once I get that, then I can solve for y. So Justin, what am I going to do here? Well, we already set these equal to each other, and I already got 13 to get x. Say it, Anthony. Plug it in, right. Plug it in for which one? Doesn't really matter which one, right? I could either pick this one or I could pick this one. Let's pick this one. I picked 6x minus 5 in the other class, so I'm going to pick this one in this class. Okay, it's still the same exact thing because they're the same angle, aren't they? So watch. Put it in here. So 5 times 13 plus 8. 5 times 13, what's that? 65, right? Plus 8 is 73. So this angle right here is 73 degrees. So, and this one's also 73 degrees, right? So you can look at it two ways. This angle and this angle, what's true about these two angles right here? They form a what? Straight line. So what do they do then? They're supplementary. Or I could say that this angle and this angle are supplementary as well, couldn't I? All right? Because they're consecutive interior angles, yeah. Well, okay, he brings up a good point. Now, sometimes they'll do this. All right, watch. Justin said this can't be 73. Why did he say this can't be 73? Because looking at the angle, what kind of an angle does this look like? Looks obtuse, doesn't it? Okay. Sometimes they do that, though. Sometimes they don't always draw them accurately. All right? But we did the math correctly. So it is 73, but don't let that fool you, because sometimes people will see that. That's a good observation. You looked at this and you said, hey, that looks obtuse. There's no way it could be 73. It must have done something wrong. No, not necessarily. Sometimes they purposely draw an angle that may look obtuse, but the numbers they put in for this stuff will make it acute. All right? Just to make sure that you know you're not just going by what the picture looks like. Okay, we don't always go by what the picture looks like. We go by the information. If these lines are parallel, and they are, not because it looks like it, it's because they tell us they are. And this angle and this angle must be equal to each other. Okay? They're both 73. You look at it and you're like, well, it can't be 73. But according to the numbers that they gave us, it has to be 73. They just didn't draw the pictures correctly, right? That's basically it. So now what do we do with this angle right here and this angle right here? Yeah, they're not equal to each other, are they?
Couldn't you do 180 minus 73?
Yeah, you could do that and figure out this angle. It's the same exact thing. It doesn't make any difference. You're still doing the same amount of steps. But I just want to show you that you add them up and set them equal to 180. So 3y minus 10 plus 73 equals 180. All right? But Anthony, you said, can't you just take this away from 180? That's what we're going to do here anyway, isn't it? Just take it away from 180, and then we'll add a 10. Or you could just do this like this. Negative 10 plus 73 is 63, right? So really, if we just take 63 away from 180, all right? Again, there's all kinds of ways you could approach this, but this is how I thought it would be best. And let's do this. What's that? A 7, and that's a 7. 117, right? And that's 3y. I did this in the last class, and I forget what it was already. What's 117 divided by 3? 39? That sounds right. So y is 39. If we did the math right on that. Is that right? Okay. And there you go. So there's x and there's y, and you're done. All right? The key to this is understanding whether to set them equal to each other or whether to add them up to 180. And I know what some students are doing in the other class and this class. I know exactly what some of you guys are doing. You're just setting everything equal to each other, no matter what. You're not even looking at it and trying to figure out if they're supplementary or if they're equal. You just kind of figure, well, most of them are equal to each other, so I'll just set them equal and take my chances. Well, don't just take your chances. Make sure that you know if they're really equal or if they're supplementary. All right? Have a 100% chance of getting it right, not a 50% chance of getting it right. Okay? So know whether they're supplementary, know whether they're equal to each other. All right, enough of that. Now, let's talk about slope. Something, something. You need to know more than that. And it's not y equals, it's slope equals. The slope equals, how do we say it? What's the phrase that we use? Something over something. Change in y over the change in x. It's the y over the x. If you listen to my third period class, I really got on them about knowing that it's y over x. It's not x over y. And so many people on the last quiz, did we do slope on the last one? Whatever quiz we did the slope on, so many people were mixing it up and putting the x on the top and the y on the bottom. I think it was the quiz before. All right? But it's this. It's the change in y. So subtract the y's, put it on top. Subtract the x's and put them on the bottom. All right? That's the slope. That's how you find slope. So let's do a problem. Let's do number 8, 9, or 10. Doesn't matter. I did 10 in the last class. Let's do another one. Let's do 9. All right, let's take a look at number 9. It says find the slope, and they give you 2 points. Hope you guys are watching. I'm trying to help you out here. I could have just given you the test today, and I'm going over this stuff for a second time. So let's take advantage of this. So we find the slope. Now you got to solve for the slope, which is change in y over change in x. Well, before that makes any sense to you, you need to know which ones are your x's, which ones are your y's. Well, the first one is the x, and the second one's your y, right? And then the same thing here. That's an x, and that's a y. So if I subtract the y's from each other, which one am I subtracting? The 9 and the minus 15, right? So it's 9 minus, is it just 9 minus 15? It's 9 minus negative 15. You going to pay attention at all today? Every time. No, don't turn around. You look at me. I won't say your name just so nobody hears it on here. No, you're not. You're not. Don't okay like that. You absolutely have not been paying attention to me today. Now we have negative 2 minus 2. 9 minus a negative is plus, and that's 24. This is add a line, change the sign. That's negative 4, and that's what? Negative 6. Okay, so the slope is negative 6. Make sure you simplify it. Don't leave it like this. Do not leave it unsimplified. Make sure you simplify your fractions. Always, always, always. If this came out to a fraction that didn't come out to a nice integer number like this, don't give me a decimal or anything like that. Okay, keep it like this right here. All right, that was pretty easy. What about this? Let's do another type of these. We've got time to do one more of these. And we pretty much did everything today. Hard to believe. Let's do this. This problem says, tell whether these lines are parallel, perpendicular, or neither. And if you can find the slope. Now, we didn't do any y equals mx plus b stuff. But that was done in the other class. We're not going to have time to do that in here. But make sure you look at that for the other class and know what to do there. Let's do number 11. We got 1, negative 12. That's C. And then S is 5, 4. K is 1, 9. P is 6, negative 6. All right, and this is what it says. Are they parallel? Are they perpendicular? Or is neither one of those things true? So how do we determine? Here's CS right here, isn't it? That's line CS between those 2 points. This is KP right here. How in the world do we know if they're parallel? The slopes, right. We find the slopes between them. If the slopes are equal, they're parallel. If the slopes are negative reciprocals, then they're perpendicular. So let's find the slope. So the slope is the change in y, negative 12 minus 4, over the change in x, 1 minus 5. So that's negative 16 over negative 4, and that simplifies to be a positive 4. Let's look at this one. Let's do the slope of this line right here. It's the change in y, so it's 9 minus negative 6 over the change in x, which is 1 minus 6. So that's 15, and that's over negative 5. That's positive 15 over negative 5, and what's that? That's negative 3, isn't it? So look at this slope. That's 4. That's negative 3. Tell me something about these two lines then. Are they parallel to each other? No, they're not parallel because they got to be the same slope to be parallel. Are they perpendicular? No, they would have to be negative reciprocals. They are not reciprocals of each other, so you would say that they are neither. Okay? That's a weird neither, but anyway, you get the idea. That's how you do it. All right, make sure you look at the third period YouTube to find that other stuff.